Good morning, everyone. Today we're going to talk about solving exponential equations. So I believe it's page 13. We're going to go through talking about how to solve these, and then you'll have some to try on your own. Okay, so let's get going on this. If you read through the directions, it tells you that you need to use properties to simplify. Then from there to rewrite the equation so that they have the same base. And last but not least, you're going to set the exponents equal to each other and solve. So what they mean by using properties of exponents to simplify, you need to remember these ones. So if I have a to the m times a to the n, that means I go through and add my exponents. If I have a negative exponent, we move it to the opposite location. So if it's negative in the numerator, it goes to the denominator or vice versa. And last rule that we have, if I have a to the m and I raise it to the nth power, we go through and multiply these exponents. So if you have more than one base that's the same on the same side, you need to combine using those rules. So if we look at example number 1, we have 2 to the x plus 1 is equal to 2 to the 9th. Okay, so I need to have one base of 2 on the left, one base of 2 on the right, which is what I currently have. So when that happens, these bases are essentially going to cancel each other out, and I'll be left with x plus 1 equals 9. And you just need to go through and solve for x. So in this case, I'd subtract 1. X equals 8. Now, here's the difference. If you were to look at number 3, for instance, number 3 has 3 to the k times 3 to the k plus 2, and then this is equal to 3 to 5k minus 1. I need to have one base of 3 on the left, one base of 3 on the right. On the left, I have this base of 3 and this base of 3, so I need to combine those together. So when I'm multiplying, that means I'm going to go through and add my exponent. So I'm going to rewrite this as base of 3. I'm going to take my exponent of k and then add k plus 2. And the reason I do this is now I have one base of 3, one base of 3, so my 3's can cancel off. I'm left with k plus 2 equals 5k minus 1. And now we can go through and solve this equation. Over here, k plus k is 2k. Since there's no squared term, you just need to be able to get your k's on the same side. So I'm going to subtract my 2k, and I'll add 1. I'm going to get 3 is equal to 3k, divide by 3, and k is 1. So that's when you already have a common base. Same rules apply for later on. We just now need to talk about how to solve those ones. Okay, so that's type 1. Let's look at type 2. So for type 2, it's going to be a little bit more work, and it's slightly different than what it was before. So if we look at number 5, we have 6 to the 2x minus 10 is equal to 36. Here are my bases. I have a base of 6 and a base of 36. They need to be the same number. You're usually going to take your larger number and make it a smaller number. So 6 to the 2x minus 10 will stay the same. But I know I can rewrite 36 as 6 squared. So now that I have the same bases, I can cancel out my bases, and I have 2x minus 10 is equal to 2. Okay, and then I can add 10 to both sides, get 2x equals 12, so x would be 6. Okay, so let's look at number 6. We have 2 to p minus 7 is equal to 8. I need my 2 and my 8 to become the same number. You're going to make your larger number become your smaller number. It's just easier. You can always start by factoring down 8. You get a 4 and a 2. And then this breaks down to a 2 and a 2. So it means I have 3 2's. And now I have a common base. So 8 is the same thing as 2 cubed. My 2's now can cancel out. And I have p minus 7 is equal to 3. Add 7 to both sides. So p will equal 10. All right, let's try a couple more of these so we get the general idea of what we're doing. Okay, let's look at number 7. We have 7 to the 4x plus 11. I don't know what that is. And then you have 1 over 7. Here I have a base of 7. Here I have a 1/7, so it's not the same. One of the properties that we talked about is if I need to move something. So if I want to move the 7 up to the numerator, it's going to become 7 to the negative 1. Because when you move something from one location to the next, you change your exponent. Now my bases of 7 are the same. They'll cancel out. I'm left with 4x plus 11 is equal to -1, and now we keep solving. I'll subtract 11 from both sides, and I'll get 4x is equal to -12. And then I'll divide both sides by 4 and get x equals -3. Okay. Let's try number 9. Okay, number 9, we have 27 to the 2x plus 6, and that's going to equal 3 to the 2x. We need to figure out if we can make 27 become a 3. Typically the answer would be yes. You can start by simplifying this down. 9 and 3 get you to 27, and then 9 can break down to 3 and 3. So 3 cubed is the same thing as 27, but I also still have this exponent right here. And when you have an exponent raised to an exponent, we multiply. So I can multiply those exponents together. And now my 3's can cancel. I'm left with 3 times 2x plus 6 is equal to 2x. Now just distribute, and you'll get 6x plus 18 is equal to 2x. I'm going to go through and subtract my 6x from both sides. I'm going to get 18 is equal to a -4x. Divide everything by a -4. X would be -9/2. Technically, you could say it's -18/4, and if you really wanted to, you could also say it's -4.5. Any of those answers would work, but this is typically the one that you would see from me. Okay, let's flip the page. Let's try it now when everything can simplify. Okay, so if we were to look at number 11, we have 125y equals 25. I need to figure out a number that the bases can both become the same thing. So if you don't know off the top of your head, I kind of recommend just trying to factor things down and notice what numbers are common between everything. I know that I cannot raise 25 to an exponent to get to 125. Nothing would work. But if you factor this, you know 5 and 25 multiply to 125. And then 25 can factor down into 5 and 5. Over here, this 25 can also factor down to 5 and 5. So if you notice, everything can be rewritten in terms of 5s. Now, if you know this, you don't need to go through and do your factor trees. I'm just trying to show people this is where the numbers are coming from. So if you know it, great. If you don't, factor them down. 125 has 3 5s, so it's going to be 5 cubed. And then I also have that y, and those would get multiplied together. So you're going to get 5 to the 3y. 25 gets rewritten as 5 squared. So now I can go through and simplify this and to get 3y equals 2. So y equals 2/3. Okay, let's try, I don't know what's a good one. Let's try 14. On 14, we have 81 to the 2x plus 5. Set that equal to 1/3 to the 2x. So first of all, you can't have a fraction as a base, so we need to get whole numbers. This one would be the easiest to change. Let's do that. I'm going to take my 3 and move it to my numerator, which makes my exponent become a negative. So 1/3 to the 2x is the same thing as 3 to the -2x. That means I now need to rewrite 81 so that I have 3 to an exponent. 81 is the same thing as 9 times 9. And then you get 3 and 3 and 3 and 3. Means I had 4 3's. That worked. And then you take your 2 exponents and we would multiply them. Now that we have that, my 3's can cancel out, and I'm left with 4 times 2x plus 5 is equal to -2x. Now we just solve the equation. We're going to take our 4 and distribute it to get 8x plus 20 is equal to -2x. I'm going to subtract my 8x. You get 20 is equal to -10x. Divide everything by -10, so x equals -2. Okay, so I'm going to skip down and let's try 18. Number 18, we're going to have to do a couple different things because my first one I have 9 to the 2x plus 4 times 9 to the 2x is equal to 1/81. If you notice, every time that I simplify, I have one base on the left, one base on the right. On this problem, I have 2 bases on the left, so you're going to have to do a couple properties. I need to combine these together. So when you're multiplying, that means we go through and we add our exponents. I don't like having these numbers in the denominator, so I'm going to move my 81 up to my numerator, and it becomes 81 to the negative 1. Now, these bases need to be the same. They're currently not. So my left side, if we wanted to simplify 2x and 2x is 4x plus 4. And then we know 81 is the same thing as 9 squared. Since it's a negative 1, this becomes a negative 2. Now I have the same bases, so we can just go through and cancel out my 9s. I'm going to get 4x plus 4 is equal to negative 2. I'll subtract 4 and get 4x equals negative 6. And I would divide and I get negative 6 over 4. This also simplifies to negative 3/2. It's also the same thing as negative 1.5. This would be the I'm looking for. Because it's fully simplified, technically any of them would work. Okay, I'm going to work through one more and then we'll be done. Let's do 19. Okay, so for number 19, I have 1/7 is equal to 49 to the x minus 5 times 7 to the x minus 9. Okay, so to get started, I don't like having a fraction, so I'm going to move this 7 from the denominator to the numerator, which changes my exponent to a negative. Since this is a base 7, we know that that 49 also needs to be a base 7. So we know 7 squared is the same thing as 49. And then since you're going to have a power raised to a power, that means we would multiply those exponents. And then I also have 7 to the x minus 9. So I need these bases to all be the same, which they are. From here, I also can only have one base on each side, so my left side is good. My right side I need to combine. When I'm multiplying, that means I need to go through and add my exponents. From here, my bases are going to cancel, and I'm left with this equation here. Now I just need to go through and simplify. Negative 1 stays how it is. On the right side, I'm going to distribute my 2 to get 2x minus 10. Then I'll have x minus 9. I can combine my like terms. 1x and 2x is 3x. Negative 10 and negative 9 is negative 19. I need to get the 3x by itself, so I'm going to add 19. Get 18 equals 3x. Divide by 3, so x is equal to 6. All right, there's a few more equations in here, so if you feel like you need any help trying to figure them out, please let me know. Other than that, notes are ready to go, homework's good. Probably be prepared. We'll have one more lesson next week and then be prepared to take another little checkpoint to see if we got the solving figured out. Have a great rest of your day. Talk to you soon.